for you last-minute studiers out there, here's a quick review of nuclear chemistry, specifically half-life. This was a request. I think it was a really good one, okay? Nuclear chemistry. So, nuclear chemistry is chemistry actually of the nucleus, okay? Remember that when you have something in isotopic notation, it'll look like this. Carbon 14, okay? That 14 is the mass number, that's the mass of the nucleus, and if the 6 is not there, you know it's a 6 because you can look it up on your periodic table. If it's a C, it's always a 6. That's a charge on the nucleus. It's also the number of protons and the atomic number, okay? This is your isotopic notation. This is your radioisotope, something that might decay, might spontaneously spit out a particle. For nuclear chemistry, your two best reference tables are tables N and O. Okay, tables N and O are going to tell you all of your different things that you need to know. Okay, they give you tons of information, like what an alpha particle is, what a beta particle is, what a neutron, a proton, etc. are. So tables N and O. Few things you need to know, and then I'll do a quick half-life problem. Natural transmutation. Natural transmutation. Natural transmutation is any transmutation that just happens, okay? It has one reactant. After our chemical reactions unit, you should know what a reactant is. I guess I don't even ask that. One reactant, okay? Artificial transmutation means you hit it with something. Okay, so you're going to have two reactants. That means you're going to have a plus sign on the left. So if it was carbon and it was just naturally decaying, it would look sort of like this. How do I tell what's left? Top numbers have to be equal on both sides of the equation, and bottom numbers have to be equal. Look up the symbol on your periodic table. That's natural transmutation. Bam. Let's look at some artificial transmutation. Would look more like this. I'm just making this up. I don't know if this actually happens. I'm going to hit carbon with a neutron, and let's say that it absorbs the neutron and spits out a proton. Okay, and so that's okay. This would be 14, and this would be 5, so it's boron. Okay, you don't have to come up with that. You just have to know that this is artificial transmutation because there's a plus sign on the left. There are two types of specific types of artificial transmutation. We have fission and fusion. Fission is division. Okay, this is the one with uranium, and it splits off into 3 neutrons. It gets hit and it breaks apart into 2 different things. Fusion involves helium and hydrogen only. Maybe some protons and neutrons, but that's it. Only heliums and hydrogens. Just because you see a helium or hydrogen does not make it fusion. Fusion is combining of light nuclei to form heavy ones. Fission is dividing of a heavy unstable nucleus into many different ones. All of these convert mass into energy, and that's why they release so much energy. Okay? That's why nuclear reactors melt down. Okay. Last bit, half-life. How do you figure out half-life? Half-life is very easy if you know what you're doing. Okay? If you make a table. I know some of you hate making tables. I would be willing to bet those of you who don't like making tables are probably not watching this video. Okay? So, there's a few types of questions, and I'll show you. Can you do them all with the table, and I'll show you a bunch of them. The table you set up should look like this. Half-life is one column, time is the middle column, and amount as the last column, okay? Half-life starts at 0, time starts at 0. That's the most commonly missed thing. People forget to start at 0. I'll make those zeros red so you see them, okay? Half-life and time start at 0. Half-lives are just going to go on one at a time. 1 half-life passes, 2 half-lives pass, 3 half-lives pass, 4 half-lives pass, and 5 half-lives pass, etc. Okay? Time, it depends on what isotope it is. Different isotopes have different half-lives. So if you're picking one like francium, it's going to be seconds. If you're picking one like iodine, it's going to be days. I'm going to pick a random one. If you don't know what the time is, you can look it up on table N. If I don't tell you what that is, otherwise sometimes it doesn't matter, okay? Let's say the time is, the half-life of this stuff is 2.5 minutes. I made that up. I don't know what it is, okay? Every half-life, 2.5 minutes pass, okay? So the next, after one half-life, 2.5 minutes go by. After the second half-life, 5 minutes have gone by. Do not just double this column. This column is not multiplied by 2. Big red X, not multiplied by 2. This column you keep adding 2.5, so then you become 7.5. Okay, then it becomes 10. Then it becomes 12.5, etc. You keep adding plus 2.5 every time. Okay? However long you need to go, and that depends on the status of the question. The amount, okay? There are 3 cases for the amount. It may tell you, okay? It may tell you start with 100 grams. Let's say, not 100, let's say 200. It may tell you start with 200 grams. That's your initial. If that's your initial amount, it goes right here. 200 grams. Make sure your rows line up, because if they don't, it's a pain in the butt. After one half-life, half is left. Unchanged, 100. After another one, half is left. After another one, half is left. After another one, keep dividing it by 2, okay? Keep dividing it by 2. So this one we divide by 2. Okay? That's how you can figure out how much is left. Go down to how much time has passed, see how much is left. Sometimes you're not given an amount, okay? If you aren't given an amount, you might be given something like, they might ask you what fraction. If you want to know what fraction is left, you're going to start with an amount of 1, and you're going to keep just dividing it by 2. It's going to go to 1/2, 1/4, 1/8. Everyone forgets 1/8. Don't forget 1/8. 1/16, 1/32. Okay? After 5 half-lives, 1/32 remains. One last way, 2 other things they might ask you. They might not give you an initial amount. They might say, after 5 half-lives, there's 1 gram left. How much did I start with? When you go back up, you're going to multiply by 2. Okay? So it's going to be 2 grams, 4 grams, 8 grams, 16 grams. If you're not doing this with a table, you have a tendency to stop at 16. But you can see that we're not done yet. That's after 1 half-life. So my initial amount would be 32 grams. Okay? Make sure you read the problem to see what it's asking you for. Finally, there's one more type of question that you might get. I don't even know if this is on your midterm or not, but you might see it on the Regents, and you can watch this for the Regents as well, so I'll include it. It might tell you, after there's a quarter left, okay? You have 1 quarter remaining, and it took 10 minutes. How long is the half-life? Okay? So, this is a fraction, so I'm going to start with 1, and I'm just going to keep having it until I get to a quarter. So I know it's going to be a half, a quarter. So I know it went through 2 half-lives. It took 10, let's say they're years. 10 years to go through 2 half-lives. What's 1 half-life? Okay? If 10 years is 2 half-lives, how many years is 1? Okay? You should easily get that 5 years is 1 half-life. That's probably the hardest type of question they will ask you, or I will ask you on one of these problems.